Hello students! The lecture today we are going to talk about the trigonometric function properties and their graphs. We already know that in general a function is a connection between elements of one set called a domain and another set called a target. And the trigonometric functions are no exception. This connection between these two sets can be seen from three distinct points of view. The first point of view, you just describe the procedure, the sequence of steps that you have to follow to connect the elements of one set with the elements of the other. From the second point of view, you just join the points. Join the points in pairs and you have a table. Okay? Then, the third point of view is our goal today, is the graph. You want to draw the graph, okay, of these functions. Well, we already seen last lecture the first 2 points of view, but let's recap them. First, the trigonometric function. The input is a real number called the angle, theta. On it, we apply a sequence of steps represented by this box, which gives an output, a number belonging to the target. The cosine function, let's label cos, is a sequence of 3 steps. The first step, you draw the unit circle. The circle which has radius 1. The second step, you're going to mark the angle. The angle you measured along the arc. Here's the arc measuring theta. At the tip of this arc, you find the point which has coordinates x and y. This is x, this is y, okay? This is x, this is distance. Y is this distance, okay? And the third step of the cosine, you just pick the x coordinate. So cosine of theta is x. So let's read it again. The cosine is the label for this particular 3-step procedure. So this 3-step procedure acting on the number theta that we chose as input yields x, okay? We already saw last lecture also the sine function. The sine function is very similar to cosine, except that instead of x, it picks y, so this is y. And finally, we saw the tangent. The tangent function picks not x, not y, it picks the slope of this line. So it's y divided by x. Remember, the slope of the line, you just draw the triangle, so it's the height of the triangle divided by the base. It's here. Okay? Now, these are 3 distinct labels for 3 distinct 3-step procedures. The first one, the cos, picks the x coordinate, the y picks the y coordinate, and the tangent picks the slope. Okay? This is the result of these three functions. Okay? Now, this is the first point of view that we saw last lecture. You saw this in great detail. This is the summary. The second point of view is you just list the pairs of the input and the output. Okay? Let's list. Here's the input, theta, and here's the outputs, x for here, y here, and y divided by x. Okay? Well, if you list all the angles, that is all the distances along the arc of the unit circle, positive and negative, all numbers. This is the real numbers. This column has all the real numbers. Okay? Well, for each one, you can now follow the 3-step procedure labeled cos, and you find this number, or you follow the sine procedure and you get this number, or follow the tan procedure and you get this number, and so on. You just repeat this for every single point. Okay? And you get the table. This table is the points x, theta x. The points theta x, the set of which represents the cosine function, because the cosine is association. Is association. Okay? On this table, we also find theta and y. Well, this is a representation of sine of theta. All the points theta y are represented. And you also find here theta y divided by x. All the list of it. You grab these points, pick them, and join them, and you have this sequence of points. Well, that's the tangent of theta. Okay, the tangent function. Okay, this is the second point of view. Notice that this table doesn't end. It goes on forever because these are real numbers. It goes from minus infinity to plus infinity. Here you can find the slice of this table. Okay, a slice on the first row. You find some of what we call the important angles, special angles. Okay, yet you find on the special triangles. On the other rows you find the outputs for this column, or this column. Okay. Notice these calculations are the ones that we can do by hand. If you want other calculations other than these, you have to use a computer. Okay? Use a computer to run this procedure and make the calculation for you. Okay? So this is the second point of view. The second point of view that we saw last lecture for these functions. Now another point of view, the focus of today. The focus of today is to make a picture, a graph. On the horizontal axis, you find the theta, the inputs. On the y-axis, you find the outputs. Well, it could either be cos of theta, or the sine of theta, or the tangent of theta. How are you going to find this? Okay? How are you going to find this? You see? Well, imagine for the moment that you and Eve are police investigators, like in CSI. Okay? And this is your three hacking suspects, hackers. Okay? Well, if you want to arrive at a certain conclusion about what they've done, then you better collect as much information about them as you can. So far, this is all we know, the procedure. Okay? And so, like good police investigators, we are going to interrogate them, make questions and get answers out of them. So, starting from what we know, okay? As you get more information about them, now you start to piece together this information and to arrive at what is the behavior of these three hackers here, okay? So let's start. What can we say starting just from this? What can we say? First, let's look at it. If you start with cosine of theta, you get the x-coordinate of this point. But notice the perimeter of this circle. What is the perimeter? The perimeter is 2 pi times the radius. But what's the radius? This is a unit circle. The radius is 1, so the perimeter is just 2 pi. That means that, well, is the point associated with theta, but what if I now consider theta plus 2 pi? Well, theta plus 2 pi, you just add the complete perimeter, so you arrive at the same point. And so what's the x-coordinate associated with this point? Well, it's again x. Okay? That means that cosine of theta plus 2 pi is the same thing as the cosine of theta. Or in other words, the x-coordinate of a point at the tip of the angle theta plus 2 pi is the same as the x-coordinate of the point at the tip of theta. Okay? The same thing with the sine. The sine of theta plus 2 pi is what? Is the same thing. Why? Right? Because the point is the same, so the coordinates must be the same. What about the tangent? The tangent is also the same thing, because the slope is the same, the point is the same. So it's a tangent of theta. Okay, now we added one full perimeter. What if you add 2 or 3 or 100? You see, you add theta and you add 3 turns, you arrive at the same point. 100 turns, you arrive at the same point. So it's not only 2 pi. You can add any multiple of 2 pi. Moreover, what if you subtract 2 pi. Subtract. If you start here and now go the clockwise, you arrive at the same point. So you can add as many multiples of 2 pi, positive or negative. The same for the sine and the tangent. So let's fix this. It's not just 2 pi, it's any multiple of 2 pi. Okay? Not just 2 pi, it's 2 pi times n. Okay? Where n is what? A number belonging to z, all the integers, positive and negative. Okay? Now, but there is something else here. I don't know if you notice. What if I have the angle theta and I add f of it? F, instead of 2 pi, I just add pi. Well, in this case, I land here. You have theta plus half of a full circle. You arrive here. What's the coordinates of this point? From the geometry, this distance is the same as this distance. So this is minus x, but for the negative side, okay? This distance is the same as this distance, but it's negative, so it's minus y. So what's the tangent? Well, the tangent of this point, the tangent of theta plus pi, is this ratio, is minus y divided by minus x. But what is this? Is y divided by x. The same result that you get here. So the tangent is different. Even if you add f of it, you get again the tangent. So the tangent of theta plus 2 pi is again tangent of theta. So you can remove these two. To make this more general, in general, this is what you have. N could either be 1, it's true, because theta plus pi is the same thing as tangent of theta. But if it's 2, it's true again, or 3, and so on. Okay? So the tangent is different. This acre behaves differently from the others. Okay? So this is what we call, this is the first property. The periodicity, they are periodic. These repeat their actions every 2 pi or any multiple of 2 pi. Well, the tangent is different. It's half of it. Okay? Now, this is the first property that we derived just from the definition of these functions. Okay? Now let's move on. The second property. What's the second property? The second property is that these functions have maximums and minimums. What's the maximums and minimums of the function? Okay, cosine, remember, picks the x-coordinate of the points on the unit circle. Well, if it picks the x-coordinates, then that means that cosine theta lives on the horizontal axis. Well, if it's on the horizontal axis, well, that implies that it's between 1 and minus 1. Okay? So the cosine is between minus 1 and 1. The same with the sine. Okay? The same with the sine. The sine lives on the y-axis, and so it's between 1 and minus 1. Okay? Now let's make this concrete. Cosine of 0. Cosine of 0. What's cosine of 0? It's the x-coordinate of this angle, measuring 0, which is 1. Okay? What's the sine of 0? It's the y-coordinate of this point, so it's 0. Let's consider this. What's the cosine of pi over 2? What's the x-coordinate of this point? It's 0. What about the sine? The y-coordinate of this point? It's 1. Okay? So this is xy, xy. Let's move on. What's the cosine of pi? The x-coordinate is minus 1. What's the y-coordinate? It's 0. Okay? Finally, sine of 3 pi divided by 2. I'm sorry, cosine. Cosine. First the x is 0 again. What's the sine of 3 pi over 2? It's easy, minus 1, okay? So you have here xy, 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 xy for all these points. The important points, okay? How do we know this? Well, because you know the recipe. You know the procedure, you just follow the procedure, and you arrive at outputs. 1, 0, 1, 0, etc. So notice that it is a maximum, either 1 or minus 1. 1 and minus 1, okay? Okay. What about the tangent? What about the tangent? The tangent is special, right? The tangent. What about the tangent? Let's put here the tangent. You can compute the tangent from these two, because recall, the tangent is the ratio. It's the ratio of the sine and the cosine. The sine, this divided by this, so tangent of 0 is 0 divided by 1, but 0 divided by 1 is 0. What about this? This is special, more difficult. What's the tangent of pi over 2? Right? Because now you have 1 divided by 0, so this is not defined. Okay? The function tangent doesn't exist at this point. What about here? The tangent of pi. What's the tangent of pi? Is again 0 divided by minus 1 is 0. And finally, what's the tangent of 3 pi over 2? Again, we have a problem, right? Because it divides by 0, so it doesn't exist. Okay? This is the second property that we can find about this. What about more properties that you can find just looking, knowing the procedures? Okay? What about the others? Well, these functions are symmetric, right? They are symmetric. Let me erase something here. Let me put here 3. They are symmetric, right? Because, let me write first, cos minus theta is cos theta. Let's see. Cos theta, it's here, it's the x coordinate of this point. Let's mark now, interpret this side, the left hand side. Let's mark minus theta is the point, minus the point at the tip of the angle, it's here. Let's pick the x coordinate. Well, the x coordinate is this. Is the same. They are the same. Is the same value. So this is true. Okay? What about the sine? Sine minus theta is equal to minus sine theta. Let's check. Sine theta, you always check step by step. First, understand what's sine of theta. Sine of theta is the y coordinate of this point, this distance. Multiply it by minus 1, so it's this distance. And now let's interpret this side. What's the sine of minus theta? It's the y coordinate of this point. Well, it's the same. So, it's the same, the two. Okay? So this is also true. What about the tangent? The tangent you can either look graphically, like we did here, or you can derive it. Because tangent of minus theta is the ratio of sine minus theta by the cosine of minus theta, right? But what's the sine of minus theta? Well, it's minus sinus theta. Cosine minus theta is cosine, so this is the same thing as minus the tangent of theta. Okay? It's good for you to check this. Try to check this from this point of view. Okay? Very important. Okay? These are the 3 properties that we know so far. Of course, we also know these. There are more properties you can derive, but I think with this we can already start to make this graph. Okay? This is good. These clues are good enough already. If you need more, we have to ask more questions to our suspects. Okay? But so far, I think this is good enough. So let's erase this. Not everything. So let's make here the final thing. Okay, here it is. On the horizontal axis, you have the input, the angles theta. Okay, the real numbers. It's a line. It never ends. It goes on forever. On the vertical line, you also have the real numbers. Okay, but on it, you are going to plot the values, the outputs of. Let's start by cosine of theta. The numbers, the real numbers, cos theta, belongs to this axis. Now, how do we proceed now? We have these clues, what we do. Okay? You start always to draw the easy points. What's the easy points to draw? It's zeros and ones. It's here. This is the easiest thing to draw. Okay? So what's cosine of 0? So let's mark it 0. 0, it's here. So it's 1, right? It's our first point for the cosine. Okay, can you see? 0, 1. Okay, Input, output. Input, output. Here it is. The next one, cosine of pi over 2. Well, pi over 2 is about here. Let's choose this point, okay? You have, so it's pi over 2 here. When it's pi over 2, it's 0. The output is 0, so the height is 0 here, okay? Let's move on. What about next? Pi. Pi is twice pi over 2, right? So it's this distance, right? Pi. And the result for pi is minus. So it's, if instead of this distance, is here, right? Minus 1. This is 1. Okay? Let's move on. 3 pi over 2. Again, you move another pi over 2 and you say 0. So it's the point, 0. Finally, you have 2 pi. Cosine of 2 pi. Let's mark it here, 2 pi. Well, you can use now the properties, because if theta is 0, 0 plus 2 pi is cosine of 0, but the cosine, the point cosine is already here. It's 1. So you mark here this point, 2 pi, 1. Okay? Is this good? Now that we have here, let's use our symmetry properties. You see, the symmetry properties, if you look at it, it connects positive theta with negative theta. See? Positive and negative. Let's use this, because if cosine of pi over 2 is 0, then cosine of minus pi over 2 is the same value. So let's mark it here. Minus pi over 2. Well, it's 0 here, it's 0 here. Just use this rule. Substitute theta by pi over 2, and you get this result. What about pi? Let's first mark pi on the horizontal axis, the input, right? Minus pi. Well, cosine of minus pi is the same thing as cosine of pi, but cosine of pi is minus 1. So it's minus 1 here as well. Here is the point. Next, 3 pi over 2. 3 pi over 2, negative, okay? Again, it's 0 here. And finally, the last one, minus 2 pi is the same value as this. Cosine of minus 2 pi is cosine of 2 pi. And so, let's make this straight. It's here. We already have outline. You see, you don't have everything, but at least you know it's probably something like this, right? Like this. Not just using our information, our answers from our suspects. You already know something about what they've done. Okay? What's missing? What's missing is the details, right? The details. What happened between this point and this point? Does it go like a straight line? Is it something crazy? What happened? You have to find out, okay? And to find out, you have to go back to the definitions of the cosine and understand what they do. Let's go. So the cosine, let's draw the circle again. Okay? And now, let's just analyze the angles between 0 and 2 pi. 0 and 2 pi, okay? Along the arc. We always focus on the horizontal axis here, because the cosine lives on the horizontal axis here, okay? This is very important, because it's the x-coordinate. It's what the cosine chooses. It chooses from the point, so you choose the successive points, like so, and you just pick the x-coordinate. Is one x-coordinate, another one, and another one, and another one, and so on. Okay? So between these two, what do you find? In the beginning, when you are here, it's 1, right? But as soon as you increase the angle, it goes inward. So it goes toward 0, right? It's 0 here at pi over 2. It goes slowly, okay? Can you see? Okay? So it must do something like this. Like this. Okay? It starts out slow and then goes faster, okay? Now, if you keep on decreasing the angle, increasing the angle, So let's analyze this from pi over 2 to pi. From pi over 2 to pi, you keep on moving the point. As you increase the angle, you pick x coordinate, x coordinate, x coordinate, and so on. You start move toward the -1. It is here. So your graph decreases. This is the point. It decreases. Okay? It doesn't do something else. It doesn't do something like increasing and then go down. It just steadily decreases all the time. You see? The steadily decreases all from 1 to -1. It decreases. Okay? What if you keep increasing the angle? It's now past this point. You are here. You always pick the x coordinate, so you live on the horizontal axis, and now you start to see the point on the horizontal axis start to move into this direction. Okay? And so that means that it's increasing from -1 towards 1. Can you see? It increases from -1 toward 1, like so. Okay? Very important idea. Okay? But now we already draw something. You already have some details of what happens in between these points. And so now let's draw this part, the negative part. But you can use the rule 3. This property of the behavior of our suspect says that every time you compute a cosine of a negative angle, that's the same for the the value is the same as the positive one. So if this does something like this, on the other side it does the same. You see? The same value, the same value, the same value. Positive angle, negative angle, but the height is always the same. The height is always the same, you see? You keep on moving. Like so, okay? Can you see? Okay. This is the entire graph from -2 pi to plus 2 pi. Let's just compare with this again. Very important idea. As you, from here to here, as you increase the angle, you see, and move like this, as you increase the angle, the cosine that lives on the horizontal axis starts here, it starts to move like this, then stops, makes a U-turn, and moves again toward 1. From 1, 0, -1, 0, and 1. Like this. Make a U-turn. That's what you see here. 1, 0, -1, 0, 1. Okay? Now, if this is clear, okay? Now let's move on. Let's move on to another point of view for the second function. The sign. Let's do the sign now. Let's do the sign in green. Let's do the sign in green. Okay, let's mark first the important points. 0, it's 0. Right? Sine pi over 2, it's 1. Sine of pi, it's 0. Sine of 3 pi over 2 is -1. And finally, sine of 0 plus 2 pi, sine of 0 plus 2 pi is again sine of 0, so this value here is the same as this, so it's 0. Okay, now let's copy. Use this property called which says that it's antisymmetric, right? It's antisymmetric. What does it mean? For example, cosine. Let's see. Cosine of pi over 2, right, is 1. -1. So sine of minus pi over 2 is -1. So if it is 1, now here you just flip it and you put it here. Okay? The 0. So if you put it pi, sine of pi is 0, minus 0 is 0, sine of minus pi is 0. So sine of minus pi is 0. Let's move on. This distance is minus, negative, right? But this flips a sign. So it moves like this. It's positive. And finally, 0 remains 0 because the sign doesn't affect it. Again, we have the outlines. Okay? You have the outlines. of the graph for the sine, and now what's missing is the details, right? The details. But you can arrive at the details by going back to the procedure that the sine represents. So let's start for step 1, draw the unit circle. Okay? Step number 2, mark the arcs and the angles. So you start moving like this, right? As you go along. Let's make like this. Okay? As you increase the angle like this, now focus on the vertical axis, because, as I said, the sine picks the y-coordinate. So the y-coordinate is on the vertical axis, okay? And so, in the beginning, when it's 0, the y-coordinate lives here. And then it starts increasing. I'm sorry, it starts at 0, it starts increasing, right? Increasing. It arrives at the highest point, here. So from here to here. From here to here, from here to here, you move from here to here. From here to here, you increase from here to here. And then, if you keep increasing the angle, keep on moving, it makes a U-turn now, and it goes down. Okay? From 1 to 0. It goes from 1 to 0. Let's move like this. It decreases in the first part, make a U-turn, and go down. Like this, and like this. And now as you keep increasing the angle past this point, it keeps on decreasing until it reaches -1. It keeps decreasing until it reaches -1. And then again makes a U-turn as you move the angle from here to here. So it increases like this, okay? Now, the difficult part. You have now to use this property to understand what the behavior is on this side. But again, it's antisymmetric, okay? So, every single time you get a positive number, you fix it. You see, for example, if this is 1, then becomes -1. So if you have this distance, for example, it goes like this. So this part becomes this part. You see? You make it negative, like so. This part becomes this part. This part now becomes this part. You see? All because this thing is true, okay? For every angle, okay? Now this is the sine in green, sine of theta. The cosine is in blue, okay? And finally, what we have left is the tangent, right? The tangent. The tangent is special, remember, because of this, right? This is special. Let's make it carefully, because we have to exclude these points. We have to exclude these points from the domain. So it's pi over 2 minus pi over 2 doesn't exist. And then 3 pi over 2, right? It must be excluded. And minus 3 pi over 2. So we start by excluding what the tangent can't be. It can't live on this it doesn't have these inputs. It doesn't have pi over 2, 3 pi over 2, and the negative ones, okay? Now, tangent of 0 is 0. We have 1 point, right? It's here. Use this again. Tangent, you see? I'm sorry, here, tangent is periodic, right? Because if tangent of 0, tangent plus pi is again 0, right? So it's 0 here, and it's 0 here, and it's 0 here, because 0 minus 2 pi, or here. Okay? Correct? Use this property. Okay. Now, let's think about it. What happens in between? You go back to the definition of tangent. The tangent picks the slope. So first step, draw this. Draw the points. Now as you choose angles, you pick the slope. So the slope starts at 0, right? And then the slope starts to increase, right? As the angle goes from 0 to pi over 2, the slope keeps on increasing, right? Increasing and increasing. So we must do something like this. Notice that it never ends, because as soon as the closer you get to pi over 2, the greater it is. So it goes to plus infinity, off the charts, okay? On the other hand, if you keep moving like this, then the slope is negative, and it keeps getting more and more negative, until it goes to minus infinity. So it behaves like this. Okay, it never touches this line. Okay, never touches the line. It just keeps on going down. Okay. Well, but we know that the tangent is periodic, right? So every single time you add pi or any multiple to pi, you get the same values. So if you start with these values, and you from here from minus pi to pi over 2 to pi over 2, and now you add pi, well, you get the same outputs. So you just copy like this, or like this, or you just copy like this, or you copy like this, because every single time you move pi, you get the same results. Okay, can you see? So this is how you derive from these properties. Is how you derive the behavior of our three echoes. Okay, here they are, these beautiful waves. Okay, now let's now move for the last part of this lecture. Okay. Well, before I move to, let me just make a small comment. Notice that I'm not 100% sure that the behavior of the function in between the points that I marked is exactly what as I said. I know it decreases. I know it decreases steadily, okay, or increases steadily. But is it like this, or a bit like this, or like this? I'm not sure which one. I don't know. I'm not sure. But qualitatively, this is good enough. Okay. Our goal as police officers is to get the best picture that we can think of. Okay. For the best picture that makes sense for the data that we have, and this is the best picture that we have that makes sense of everything that we know so far. Now, if you want to be rigorous, well, you just can use a computer and compute this thing, okay? But you see, well, if I can use a computer, why do this anyway? You can ask that, okay? Here's why. Because as you do this, as you identify the properties, you start to understand why the justification, why this thing behaves in a certain way in certain regions. You can get that from the computer. In the computer, just put the formula and press OK, and everything appears in front of you. But if you just study each piece, you see, in a sense, each piece of the crime, you see, each part of the data that you have, each evidence that you have, starting making a complete picture of what happens. And once you have all the most of the evidence, you can now fill in the details. Okay. The idea is that you get more than just a picture if you go through this process. You also know to justify the things that you see. Whether when you are with the computer, you can't do that. You just the things disappear. But of course, you can use a computer after you have done this, or to check this. Okay, you can use that. It's a good idea, in fact, to make sure. Now that you draw your pictures, to confirm that you are indeed correct, okay, or to get more detail. The computer can tell you exactly what this point is, okay. Well, while here I just think that, well, it's somewhere along this line, okay. You see, this is the important idea. Well, let's move on to the last part of the lecture. We are going to derive one more set of properties for our suspects, okay, which will be very useful in practice, because, let's see, so far we only know how to compute the cosine, sine, and tangent of those functions. That's what you know, is that. But what if you see a cosine or tangent or a sine of an angle that it's not one of these. What if you have something, for example, sine of pi minus pi over 3, for example? Well, this angle is not on this list. Well, you could use a computer, of course, but what if you don't want to? What are you going to do? Well, again, the idea is go back to the definition, to what the sine do as a procedure. So let's draw, first step, draw the graph, the unit circle. You mark this angle carefully, okay? Let's mark the angle. Let's choose another color, mark the angle. Well, pi is from here to here, right? It's 1/2 of the full circle. Pi over 3 is you can divide this by 3. Let's divide this by 3. It's like a pizza, right? Half a pizza divided into 3 slices, 1, 1, and 1. From here to here, it's measuring pi over 3. Well, okay. Why? Because from here to here, the arc measures pi. From here to here, it measures again pi over 3. And from here to here, it measures pi over 3. Okay? The length of these arcs is okay. So it means that pi, the half a pizza minus a slice, is this from here, from here up to here. This is the point, the final point of the arc. This point has an x and y coordinate. Let's mark this x and y coordinate. Is the x coordinate? Is the y coordinate. X and y. Okay? Now, the idea is I want to relate this with something else that I can compute. And what I can compute is on the first quadrant. So let's draw here, like so. Okay, this is good. And now let's mark pi over 3 here. Pi over 3. Here it is, the pi over 3. Here's the point. Here's the x. And here's the y. Let's give it different names. Y prime and x prime and y prime. Okay? Now notice the following. The sine picks the y coordinate. This distance. And this distance is the same as this distance, right? And so we say that the sine of this is the same as sine of this. Okay? In other words, the y coordinate of a point at the tip of an angle pi minus pi over 3 is the same as the y coordinate of a point at the tip of an angle pi over 3. Okay? Is this okay? So it is indeed correct. What if it's a plus? So this is plus. What if I put here plus? If I put plus, you have to add. You have pi plus pi over 3. So you land here. This is the final point of the arc. You again have a y coordinate. This distance, again, is sine of pi plus pi over 3. Okay, this distance. How are you going to relate to this? It's the same, except for the minus sign, right? So you put here minus. If it's minus here, you put here a plus. If it's plus, you put here a minus, right? So here's the idea. The idea is this. You start with a sine of an angle on the second, third, and fourth quadrant, and your goal is to relate it with an angle on the first. Okay? Why? Because on the first you can do calculations like this. Okay? Let's make this general now. Let's make it general. Let's do it like this. If you have the sine, you see, the idea is this. The angles that you find on the unit circle can be decomposed, can always be decomposed, can be decomposed into a main part, plus something, let me explain. The main part is either the main part of an angle. Okay? The main part is either 0, pi over 2, pi, or 3 pi over 2. That is, the angles start here, 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 or here. This is the main part. Any angle that you have can be decomposed into a main part plus something. What's that something? That something is an angle that belongs to the first quadrant. This is very important that you are able to do this, to decompose your angles, whatever they are, into two parts. The main part and the something that belongs to the first quadrant. Okay? Now the idea is this. This angle is one example, a main part and something, because pi over 3 belongs to the first quadrant. Now I claim that you can, if you have a sign of an angle written in this form, then this is the same thing as this. This is the key part. So let's see. Is the same as f of evaluated at the something. Okay, f of something. Okay, f could either be the sine or cosine, or in other words, the x or y coordinates of the point at the tip of something. But you need to fix it, you see? You need to fix it because you have to multiply this by the sine. So the sine could either be plus or minus 1 times f could be either be sine of cos evaluated at something, that some angle on the first quadrant. You can see this pattern here. Here's the main part. Here's the something, the angle that belongs to the first quadrant, is equal to a sine. In this case, f is the sine, and pi over t, which is a something. You see? I'm going to make this in color to make this obvious. You see? Just compare the colors and the sign. Let's put the sign in green. It's easier probably for you to see. Sign. The sign is here. Okay? Can you see the pattern? In this case, f, which is in black, this is f, turns out to be the sign. Okay? Okay? Now let's give another example of this for you to understand. But before moving to that, okay, I almost forgot. Let's see this here. Okay, this is very important. Okay, pi over 3. Let's go it slowly. Pi is from here to here. Pi divided by 3 is, you just divide this by 3. Here it is. So this is pi over 3. And this is pi minus pi over 3. Can you see? These values on the horizontal axis. Pi over 3 minus pi over 3 and then pi. Okay? Maybe I should put these like this. Okay. Now, the sign of this value is this height. Right? And the sign of pi over 3 is this height. Okay, the graph is not perfectly symmetric, but I think you get the idea. This should be exactly the same, okay? It should be the same height, okay? It should be like this, okay? But you can see that in the graph, you can see it. Let's take another example, pi plus pi over 3. Well, pi over 3 is like this, so it's like this. Pi over 3, pi plus pi over 3, it's here. Well, the sine of that angle is this distance. Okay? Well, these distances are pretty much the same, just except for the minus sign. You flip it and compare, just like so. Sine of this with the plus, minus, downstairs, sine pi over 3, okay? So you can see this here as well. Okay. Now let's move on to a last example. For today, you could do it here. Last example. Last example. Let's take the cosine this time. The cosine of 3 pi over 2 minus theta must be equal to a sine, which I have to find out, times f evaluated at theta. Okay? Our goal now, you see, I don't know how to compute this. So my goal is to reformulate this into something that I can compute. Well, the sine could either be plus or minus 1. F could either be sine or cosine. How am I going to find out each one? Well, you make a picture. This is an exercise in geometry. Okay? So you start by marking 3 pi over 2. 3 pi over 2 is go up to here. This is the point at the tip of 3 pi over 2 minus theta. You are here. Let's just assume for the moment that theta measures this. So this distance, theta is the length of this arc. So the length from here up to here is exactly 3 pi over 2 minus theta. Okay? What does this say? The third step of the procedure, you pick the x-coordinate. And the x-coordinate, is this distance. Okay, can you see? Okay. Now, what does it say? Sine of f of theta. Well, f is a trigonometric function. Okay? So you follow the same procedure. Draw the unit circle. Let me put it a bit better, like this. First step. Second step, mark the angle theta. Is the angle theta. Then the point at the tip. Now, f could either be the sine of the cosine. I don't know. So it could either be this distance, the x-coordinate, the cosine of theta, or the sine. Okay? This distance or this distance. This distance, it's like this distance, right? Except for the minus sign. Can you see? Okay, but if it's this distance, it means that f is in fact the sine, because you have to pick the y-coordinate, and the sine, that's what it does, and you have to choose the sine to be minus 1. So you conclude that cosine 3 pi minus theta is minus sine of theta. Okay? Let's see this from this point of view now. 3 pi over 2 minus theta. Let's make theta like this. And I don't know if this is very small, but I make it like this. So this thing measures theta. So 3 pi minus theta is like this. Okay? Okay. Now, pick the sine of theta. The sine is the green one. Here it is. What about here? The cosine of this angle. It's like this. Can you see? This distance is almost the same, except for the sine. Can you see? Okay? It's harder to see here, okay? But here is much more easy, okay? Okay. Pronto. So, why this is important? Let's just focus on this now. I already give an hint, but again, you only know by hand how to compute the cosine and the sine and the tangent for special angles. Every single time you have an angle on the second, the third, and the fourth quadrant, your goal is to reduce it, is to reformulate it like this, okay? If you belong to the second quadrant, you usually have to write pi over 2 plus something. If your angle lives on the third quadrant, you write pi plus something, and so on, okay? Or minus, by the way. You just have to choose what's best for you, okay? This is how you decompose the angle. Decompose it into a main part and a something. The angle in the first quadrant. And then you just reformulate like this. It's a sine times f evaluated as a something. And this part you don't know how to compute, but this one you know. And so, because they are the same, you indirectly know how to compute this thing. For any quadrant, you can do this, okay? In fact, you can find tables of these formulas. You have tables. You can find it on the notes, in the description. You have a table with all the formulas that you can get for the sine, cosine, and tangent, all of them. But the most important idea is that you don't have to memorize them. Just don't waste your time doing that. Just spend your time trying to understand this. And do like this. You derive the formula using geometry and using the definition, the procedural definition of sine, cos, and tan. Okay? So, this is all for today. Again, you have the notes in the description, which also have the exercises. I wish you a good work and see you next time. Goodbye.